number of people. I'd like to thank all the co-authors who were very, very valuable to me in assisting in getting hold of the data that we are trying to present today. It also covers data over a period of approximately 30 years. I first started doing analytical work on Suva Lagoon in 1978, and I've gone and then in different ways been collecting information on it, either myself or with collaborators over that 30-year period. So remember, we are dealing with a highly urbanized lagoon system. These are coastal water bodies surrounded by large population centers, and around the world, areas like this have been shown to be polluted. This problem is enlarged when the water body is also a major port, because ports bring the additional attribute of shipping and all the associated transport infrastructure, which can in itself contribute a major contaminant load. There's a range of contaminants that could occur, and that depends on the particular local activities. So, when we look at the situation here, what might be of interest? Well, we heard about nutrients yesterday, and I'll say a little bit more today, mainly from sewage and related runoff, but it could be from agriculture if there happens to be agriculture of significance in the area. Metals we heard about from John Michel yesterday, and I'll add a little bit more to what he said yesterday. Hydrocarbons, oil-related materials, and also other things like contaminants arising from poor burning, which I'll come back to later on. Pesticides and related things, particularly the ones that are long-lasting in the environment, the organochlorines that tend to hang around. Microorganisms, generally associated with poor sewage treatment and management. A range of microorganisms, which I'll talk about one group and mention something about others. And then there's a bunch of other things that are general contaminants around the area: plastics, tires, clothing, all the general rubbish that we have moving around in our environment. And as you know, there's plenty of it here. One of the things that I try to do is, when you're thinking about assessing contamination, you think about, well, where could these materials come from, and how much are they? How much of them is it to deal with? Because by doing that, if you have limited resources, you can use those most efficiently to try and quantify the impacts that they're having on the adjacent water body. So we could have impacts from industry. It could be direct discharges, could be licensed releases. There are a number of potentials. It's poor waste management in general. It could be from domestic sources, it could be from commercial and industrial facilities. Here we have at least 7 rivers run into the Suva Lagoon, so all of those rivers have the potential to carry contaminants into the lagoon. Urban runoff, direct urban runoff during stormwater events. You know yourselves, you've seen it, when the rain comes, the water runs down the streets, picks up all the stuff that's lying there, and carts it over the surface into the stormwater drains and straight into the oceanic waters. Ship spillage and leakages, these occur in many ports. There's better management now than there used to, but there's still potential there. Shipbuilding, you have a local shipbuilding facility, and that in itself can also be a problem. And then you have atmospheric additions. I won't talk about those, but there are many situations around the world where the actual atmospheric contributions from a large metropolitan area represent a significant component of the contaminant load. So where are the sources and where are they met? We've heard about most of the places. You can start off, things might come down the river. We'll talk about that, but it's not likely to be a major source because there isn't a lot of industry there, but it could be bringing the nutrition component that Millika talked about yesterday. The Senior River, Kanoya Sewage Treatment Plant gets a lot of discussion. Samambula River, the Wadawanga River, each of those have small industry sites associated with them. Those small industries are poorly managed as a general rule in terms of their environments, and so they are potential sites. Right on the other side, you've got the Walu Bay industrial area, you've got the Tamavua River, the old Lamy rubbish dump, and you've got the Wailanda Industrial Estate and the Lamy River and that area. So you've got all of these as potential sources. So we know where the sources are, we know, and we can quantify by knowing what's going on in those catchments. And it's interesting that 10 years ago, no more than that, 15 years ago, we actually did a survey around Suva of the potential sources of contaminants into the harbour, and there were numerous of them. There were hundreds, literally, of potential sites. I don't think that's been updated, so that was done, I think, by Ken Cripps in 1990, a student visiting from Canada, and I don't think it's been updated, but it may have been. But we can easily identify, if you want to, what the sources are and what the amounts are likely to be. So a little bit about nutrients. You heard a lot about them yesterday. I'm just going to give a little bit of additional information. Hope it won't confuse you. I'll try not to. But basically, we're interested mainly in the behavior of two elements, nitrogen and phosphorus, because it's been shown that they are usually the elements that control the biological activity in our coastal water systems. Both elements can occur in nature in a number of forms, and that makes the study of them and the interpretation of the results quite difficult. They can occur in the solid material, it's suspended solids that are carried over land and through the rivers into the coastal waters. So they're present in particles. They're present in organic forms. Organic forms can be soluble, it can be dissolved in the water, or they can also be in the particulate forms. And they can be in the inorganic soluble forms, and that's complicated in the case of nitrogen because there are three of them that commonly occur: the nitrate, the nitrite, and the ammonium. So all of that makes both the collection of the data and the interpretation of the data problematic. And that's why when we have discussions among ourselves, the people who work in that area, you often have to sit down and say, what specific data are you talking about in order to understand each other's results? The other thing about nutrients is that their effects depend on the total amount of the elements present, but also on the relative amounts. In other words, we can have a situation where you might have one element present in a very large amount and might not have a dramatic effect. And that's because of a very old law, the law of the minimum, which says that the productivity will be controlled by whatever factor is present in the lowest relative amount. And so therefore you might have all the other things except phosphorus being present in large amounts, and phosphorus would be the limitation. And so you need to know which one is the limiting element and why. And different organisms have different preferences. Many organisms have a general, they like to have the nitrogen to phosphorus ratio about 15 to 1. If you do it on a molar ratio, if you want to do it on a mass ratio, it's about 7 to 1. So some organisms can work outside that ratio very efficiently, some can. So all other things being equal, if you have a biologically consumable nitrogen to phosphorus ratio that's much greater than 15 to 1, that means the system is phosphorus limited, and if the ratio is much less than 15 to 1, it's nitrogen limited. If the N to P ratio is about 15 to 1, any extra nutrients added to the system, the productivity will increase, with the fastest growing species usually doing best, the ones that are most aggressive in terms of using the nutrients. The fast-growing species are often algae, and so when you have surplus nutrients, they tend to grow most rapidly. They outcompete the corals, the planktons, and other things. But the competition is not always that simple. So in Suva Lagoon, we've got nutrient data for about 25 years. There are issues because people have used different methods. The quality control hasn't always been there, and I include my own data in that. Some of the early data we did, I'm not ashamed of, but I know there are problems with it, and people have collected different parameters. And so even though we've got that 25 years of data, putting together a trend pattern over the 25 years is extremely difficult. The nutrient concentrations are often very high. That's a general statement. You can get dissolved inorganic nitrogen, which Milika talked about yesterday, from values from 50 to 450. How does that compare with what's in the ocean? Micromoles per liter. The ocean should be about 1. The ocean values are about 1. For dissolved inorganic phosphorus, we're getting values in the range 8 to 12, and you can get in the open ocean values of around 0.1. So these are significantly higher than the values you'd get in the open ocean. Milika talked yesterday about the nitrate versus the ammonium ratio. When we have the very high values, you usually find, I found in our data, that there's more ammonium than nitrate, but it does vary from place to place within the bay. If you're near the Condoya sewage treatment plant, there's higher ammonium than nitrate. If you're at the mouth of Nambucalai Creek, exactly the same. But in other places, the nitrate ratio may be higher than the ammonium. So I've just clumped them together for the purposes of this discussion. The varies value with the tide, because the tide flushes the material in and out. It varies with the season, and it varies with the runoff from the land, because in wet weather, you get a lot more water transported from the land into the ocean, bringing with it a lot of these nutrient elements. So your values have to be interpreted a little bit with care based on where you are seasonally and in terms of wetness. At sites near the reef, when you go out away from the near shore environment, almost exclusively find the values are about the levels that you would find in open ocean waters. You get very occasionally numbers that were higher than these open ocean values. And this fits with what Malika was talking about yesterday, about every high tide the water flushes in over the top of the reef, brings with it predominantly oceanic water, gives you predominantly oceanic values, and dilutes the water adjacent to the reef. So if you wanted to get higher values in this, you would have to be going on an outgoing tide after a very heavy rainfall event, and that's where our data is higher than that. So we have a reasonable understanding. Yesterday, Pascal said that he thought from his data the system was phosphorus limited. From our data, based on the chemical information I've got, I think it's nitrogen limited. But it doesn't matter. We can interpret the data differently because we're using different approaches. The main point to make over is that in both situations, this system is very susceptible to contamination from nutrients. And we have to make every effort we can to try and minimize the nutrient load into it if we're going to protect particularly the near shore area, or redevelop or reclaim and get nice clean water in those near shore areas. Metals. Jean-Michel spent a lot of time yesterday presenting a lot of information. I'm not going to repeat what he said, but there are some other bits of information available, as well as the excellent data that the IRD group have produced. Same point I'd make about the metals as with the nutrients. They can occur in the sediments, in the lagoon in different forms. They can be dissolved in the water. They can be in the suspended solids, the material that floats about in the water. They can be in the sediments, and they can be in the organisms that live within the system, either the shellfish in the sediments or the fish in the water column. So again, we have to think about, when you're looking at the data, which component of the data are we examining? For Suva Lagoon, there are very few data that I would say are reliable on metals in solution. There are a few, but not very many. For metals in suspended solids, there's a little bit more data. The good thing about that is the data we've got indicates that there are no real problems associated with metals being moved around in the suspended solids. And I'm talking mainly there about materials coming down the Rewa River, because that's the one for which we have the most data. For metals in shellfish, I'll come back to the sediments in a minute, but for metals in shellfish, we have data for a number of shellfish species, particularly for Anadara, but also for the mangrove oyster. And again, they show very few problems. The data that we get in the Anadara collected around here, when you can find them, show that the concentrations are similar to those found in the Astrolabe Lagoon, which is considered a relatively pristine area. The metals in the sediments, you heard yesterday the IRD data. There's been data done by at least 5 graduate students here at this university as well that I've got access to. The good thing about all of the information that we've got is that the general pattern of the results is the same from everybody's data. The values that we get are relatively consistent, and so are the patterns. So that's always good to know. We seem to be doing a good job on our metals and sediment studies. The metals, sediments in the lagoon, as we know, we've heard about a couple of times, arise from 2 main sources. They either come down the rivers off the land, or they're marine, coming basically from the reef production systems. These sources have different metal characteristics, and this means that as you move from the land out to the reef, that you would expect to get a change in the pattern of metal distribution, because the metals in a reef sediment are differently distributed from metals in a terrestrial sediment. So we'd expect. That also means that you have to be careful in interpreting the results, Are you seeing a change because of pollution, or are you seeing a change because of the source? Again, the metals in the sediments can be in different forms. They can be the easily extracted form that Jean-Michel talked about yesterday, the adsorbed form. Or they can be bound into the carbonates, into the oxyhydroxides, into the aluminosilicates, or even into sulfides if you get just a little bit below the surface. And so again, when you're looking at the data, are you looking at the total? Are you looking at a particular fraction? And different people use different methods to get the total, so again, you've got to be a little bit careful in interpreting the information. But there are patterns that have been found. First one, very obvious. As you move out towards the reef, the carbonate influence greatly increases. You can see it in any measurement you make virtually on the sediments. There's increased amounts of carbonate, there's increased reflections of the pattern of metals you'd associate with that. The concentrations of metals of concern. Now I'm talking here about mercury, cadmium, lead, tin. Those are the metals that are really of health concern. They increase near the shoreline. They are not generally a problem out near the reef. The high concentrations, where we have found them, and they are going to be pretty high, some of them, have always been found near places that you could have predicted, the hot spots as they're commonly known. The Lamy Dump, the Lamy Industrial Area, the Wallu Bay Industrial Area, the mouth of the Vatawanga River. There are a number of places like that where you would expect, because there are metals industries located there, and if they're badly managed and their waste is able to escape easily, they're going to end up in the adjacent sediments. So that's what we find, exactly where you would expect those concentrations to occur. One of the things that I've done, slightly different, Jean-Michel, I took the data and I took an assumption that carbonate sediments have no aluminium in them. Terrestrial sediments have a significant amount of aluminium. So you can do what we call, in chemical terms, normalize the data. So this is a slide for two elements, copper and zinc, of normalizing. Plot the aluminium concentration against the concentration of the metal. And if there's no obvious additional source, these should form a reasonably good straight line. And as you can see, for most samples, they lie relatively close to that line. So that's good. But for every element we've ever looked at, you always find that there are a few, like this, that lie outside the normalization line. And when you look at where those are, they are almost exclusively at the mouths of rivers. This is for Lauthala Bay, and the outliers are for the mouths of the Samambula and the Vatawanga rivers, exactly where you'd expect to find them, because those are where the pollution sources are likely to have occurred. You all had a big holiday last week. Suva's the Fiji were the world champions, yes? We got another. Mata, stand up, please. This is our world champion. You people don't know, this is Matakita Mata from the chemistry department. He holds the world record for Kai-butyl tin in this marine environment. How many of you knew that we had a world record holder in the room? We've got another world record, so I'll be interested to see what happens with the world record. We've got the highest reported values in the literature. I'm not saying there haven't been values higher found, but they haven't been reported. Up to 360 micrograms per gram. Micrograms per gram are pretty low, but for tributyl tin, that is a very large amount. Most places around the world would be 1 or 2, or preferably 0. So we've got particularly high values located here. And they're located, as you might expect, near shipping operations, particularly shipbuilding facilities. Anywhere where you're scraping down and repainting boats, or you have boats which are used, tributyl tin is used, for those of you who don't know, as an antifoulant. It's been used for many years. It's now on a hit list of chemicals to be taken out of circulation, but there's still lots of it around in the environment. The tributyl tin, when it gets into the environment, breaks down. It breaks into a monobutyl tin, MBT, or dibutyl tin, DBT. And we can use the decomposition products to help us understand something about the history of the tributyl tin occurrence. So the monobutyl tin, tributyl tin ratio is used to assess if the discharge is recent or not. Low ratios indicate a recent discharge. What's the situation like? So Mata and his colleagues have looked at this for this region, and they find the values are usually greater than 0.1. which indicates that the discharges are usually not recent. In one or two places, the value is just below 0.1, but not very far below. So there's no evidence of ongoing, continuing, recent discharges of tributyl tin. Tributyl tin is a toxic chemical, very toxic. That's why it's used as an antifoulant. But the other complication with it is it has a dramatic effect on many mollusk species. It actually causes a sexual deviation, so you completely disrupt the reproductive systems of those organisms. So by having large amounts of it around, they're going to influence not just the sediment population close to the area, but it will move away from that location and influence a whole range of other organisms which themselves may not be located close to the point of discharge. Okay, go away from metals now. You've heard enough about them. The hydrocarbons. We have minimal data. Seems to have been collected. I've asked around, has anybody got any data on hydrocarbons? And I can't really find very much at all. The people at IAS have collected some data, which I'll talk about in a minute, but that's just about it. And what they have collected is data on oil and grease, which you collect a water sample, and then you measure the oil and grease content together. And they've been measured around the King's Wharf and Wallow Bay since at least 1985. So there's a 20-year collection of data. The values range from 24 to 62 milligrams per litre back in the 1980s. And last year's data showed a range of 0 to 5. And you heard this morning from Captain John that they'd moved to clean up the operation of the boats in the harbour. Stop them pumping their bilges out, stopping putting all their oil into the harbour, and that may well be reflected in this data. I can't find any data on polycyclic aromatic hydrocarbons. They are of major concern in a number of places because these are carcinogenic chemicals, and they can get into the marine environment and therefore get into the food chain and then into people's diets. I can't find any data around here at all on that. I've just been in Guam working for the last month before I came here, and they have quite a lot of data on PAHs in their harbours. And they have found, even though their harbours probably have, in some cases, larger amounts of fuel being used, very low concentrations in sediments, and very low concentrations in organisms, and the only place where there are really any significant amounts was near a large naval fueling facility where you might expect some spillages or other components to contribute. Basically, from that, I would suspect here they are not a problem. Organochlorines, persistent organic chemicals that once they get into the environment create a range of different problems for organisms, and the fact that they stay around for a while means that they present an ongoing problem, even though we may not have used them for many years. So the work, which I did with a few colleagues about 10 years ago, was looking at things like DDT and its derivatives, other organochlorine pesticides, and some polychlorinated biphenyls, PCBs. So we collected a range of data from sediments, from shellfish, and from a range of farmers' fields where DDT had been used. The data is limited. It was done in one study over about an 18-month period, and I haven't found any other data since then. Good news is that there were low concentrations found. You'd ideally like to have none, but there were low concentrations of PCBs found, up to 30 nanograms per gram. DDT and its relatives up to about 14 nanograms per gram. Dieldrin is the largest single organochlorine pesticide at 8 nanograms per gram. Ideally should be 0, certainly less than 1 on the scale that I'm using here. So where did they come from? Well, again, we're pretty sure. The organochlorine pesticides were used significantly here up until 1980, partly in the city, mosquito control programs, and partly in agriculture. Just for interest of those of you who want to know, we did find higher DDT values going up the Rewa River than we did anywhere around Suva Harbour. The PCB losses probably from the old FEA generating facility adjacent to Nambukalai Creek, some leakages or spillages from there into the creek, down into the harbour, and the largest area was found not far from the exit of Nambukalai Creek. I have not been able to get any data on organochlorines in shellfish, so I can't really give you comment. The data that we do have is for sailfish that we sampled in the Raver River, and the values there showed no PCBs, which is good, which is expected because they weren't used in that, and the DDT values were below what would be considered a health risk value. Okay, microorganisms. There are lots of microorganisms, as there are in the air around us. There are lots out there in the marine environment. There are several methods that people use for assessing their impacts, but most of the common data that's available locally is based on estimations of fecal coliform counts or concentrations. Fecal coliforms themselves are not specifically a health problem. They are produced, we produce them, we discharge them, so do all other hot-blooded animals. So we discharge them. What they are useful for is an indicator of sewage contamination. In other words, fecal coliforms that we produce go into whatever we use for a waste management system. We then work through that, and they can work out into the adjacent water bodies. They tell us that the system is not working, it's not reducing the microorganism count. We had a discussion before lunch about septic tanks. Septic tanks do reduce the microorganism count a little bit, but they certainly get through the system and get out. So we use them as an indicator, but they themselves are not the problem. The problem comes when the sewage also carries typhoid, cholera, and other more seriously pathogenic organisms. The data we have over the last 30 years shows that the fecal coliforms per 100 mil, this is the standard way of recording them, the values range from anything from 0 to greater than 10,000 counts per 100 mil. You might say, well, what does that mean, not to 10,000? Well, you go and look up anybody's, almost any country's recommended data for swimming water, primary contact. The values vary a little bit from country to country, but they're all around about 150. So, how many people have gone swimming in Suva Lagoon, close to the shoreline, which is where these all occur? So you can get some very large numbers. The interesting thing is that people have, we started this work way back in the early 80s, people have continued it. Ed Anderson's been doing it with his class for how long, Ed? 13? 12 years. So the data's been generated. The interesting thing is that there's virtually no change. This is Ed Anderson kindly provided me with this slide. It shows this sort of pattern. The average for 2005 are in blue, and the average for the last 10 years are in red. And you can see that really there isn't a lot of pattern. The thing that worries me about all this covers a whole range of sites around the lagoon foreshore. Don't know whether you can read them, but this is 10,000, 20,000, 30,000, 40,000. These are really high numbers. So because these numbers are down here at the bottom, does not mean that they are safe water. Many of them are well above 150 fecal coliforms per 100 mils. That's considered the safe bathing water requirement. The other problem is that shellfish consume microorganisms, consume and then accumulate microorganisms in their body tissues. Around the world, again, there are health regulations with regard to that, but most people recommend something around the range of less than 2 fecal coliforms per gram of fresh weight is considered to be minimal health risk. What did we find here? Well, in one system, because we couldn't find enough Anidara, Lycosa that we wanted to work on, we had to use the mangrove oyster. We got values of anything from 1 to 24,000 fecal coliforms per gram, well above anybody's safe eating limit. Now, there may be a problem, there may not. It depends what you do with your oysters, whether they actually are contaminated or not. One of the ways it's easily done is you can clean them, put them into some clean water, let them sit overnight, and that can usually reduce the numbers dramatically. Or if they're cooked, and cooked properly, then you find that the numbers are lost. But if you're eating them fresh, then you're running a significant risk. Other contaminants. This is a very quick run through of them. Plastics, tires, clothing, general rubbish. They're all out there. This is the Samambula River. I just happened to be here in November, just drove across the bridge there at Samambula River, and this is all I could see. So you've certainly got plenty of stuff going into the river, and from there it's going to end up down in the Suva Lagoon. Go around this area quite often, you'll come across things like this. One of my favourite stories is just about drums. You come across them. What was in them before? Were they empty? Were they full? Was it something valuable? Was it a toxic chemical? We've got no idea. And so you come across these things all the time. Poor waste management creating a problem. For these sorts of contaminants, there's no systematic data collection. You can go and you can find individual reports. Somebody looked at it for a month. Somebody looked after it over a year, maybe twice in 1 year. But there's no systematic data collection. It's probably not considered important, but it is important. The problem is likely to continue until we get an effective waste management system in place and working. And I know a lot of people are working on that right now, but I want to just emphasize that the problem is us. We create the waste. We should be managing it to try and protect the environment that we want to use. Progress is developing with waste education. You see programs in the news, on the TV, articles in the newspaper, and I know there's items going to the school education, but we've still got a long way to go. Okay, just to conclude, there are numerous contaminants that have been identified in Suva Lagoon. Unfortunately, although there's been a lot of work done, there haven't been many long-term systematic studies to show whether there are trends increasing or decreasing, moving from one location to another. For most contaminants, the concentrations of real concern are near the shoreline. As you move out towards the reef, almost everything decreases quite dramatically. We've identified, and people know about them locally and have done for many years, several hotspots. We know where they are, we know what the problems are. How we deal with them is another question. The sewage-related contaminants, the nutrients and the microorganisms are, in my opinion anyway, the most critical issue because they are the most widespread and probably the most difficult one to actually address. If we don't address them, then you can have two choices. I'm going to stop there, and does anybody get any questions? I'll try and answer.
Thank you, John, for that good summary of pollution studies that have been done in Suva Lagoon. If anyone has any questions regards things?
Yeah, if you're a kid growing up at the Botswana River mouth, you spend all your afternoons playing in contaminated mudflats, you can eat seafood and shellfish collected from the area. What's going to happen to you? How's it going to affect you?
Basically, you'll get sick and you'll continue to be sick and you'll have chronic sickness. Yeah. And basically, that's what happens is you find, people say to me, have you ever been able to relate this back to health problems? The difficulty is it's hard to relate particular health information back to problems like this because there are so many other potential sources that people can come in contact with. My opinion is that if you go and look at the health data, you'll find there's a lot of information about people who are chronically ill with diarrhea and related problems because they're getting infected from a number of sources and then reinfected. This is one of the potential ways in which that could happen. It's not the only one, but it certainly is one. Ed?
Yeah, I mean, on that point, that's the one thing you think about when you do go swimming. It's interesting that there isn't more sickness, though, isn't it? I mean, there really does have to be a pathogen there with the coliform before you actually get ill. Otherwise, you never go swimming because you'd be negative.
My response to that is we've been very lucky.
Yeah,
because there are outbreaks of typhoid and cholera here from time to time. I'm really surprised they haven't spread a lot more. I know they don't live very long in the marine waters, but it's just surprising. And the other thing which Bill and I have talked about many times is we don't really actually know about sickness. The health statistics are not terribly reliable for people who have what they call a minor illness. If people are really seriously ill, then there's good data. But diarrhea and related things, they're not systematically collated particularly well in the health statistics. And so we don't really know how sick the people might be. And therefore we can't relate it back to any particular problem of this type. Jean-Michel.
Yes, it's not the information that the question really. Yesterday in the two presentations we omit to talk about the analysis performed on water, and we did during I don't remember
last week,
perform some analysis on water and in sediments collected by sediment traps. So if you wish, you can contribute to this.
Okay. you and I need to talk about who puts what in which paper when we do the write-up. I'm quite happy to work with you. You do whatever part you think you want, and I can just complement that. So I know there's what Jean-Michel is showing for those at the back, is that the IRD group have got lots of other data that wasn't reported yesterday, which we could add into the database that we are developing on the lagoon, and I think we should take advantage of that offer from them to make that data available. Hand up.
Well, a couple of questions. One, Stan, did you know it was reported in New Zealand that all pleasure boats coming into New Zealand are defouled in Fiji because they won't allow them into New Zealand? And then maybe he's done it over at the Gill Net Drive, I don't know, but it's being done here supposedly. Another
New Zealand's had it since 1992. New Zealand's had a ban on the use of TBT on boats less than 24 metres.
When pleasure boats were brought into the Gulf of New Zealand, Materia mentioned that there are it's illegal to dump oil anywhere, and that they're did you report on that? They're actually taking it to ammonia and dumping it at night in the mangroves? Is that right?
There's a concern, but there's no place where you can properly discharge or dispose of oil.
Why don't they do it? Take it to partners that stay like all the other countries? Because that's what happens in Congo and Kiribati. They just collect the oil and ship it back to Suva for combustion in the filters in the state.
Some people just take it straight from the oil.
I mean, it's got to be organic. They do it there for that reason. There's no reason why oil recycling is perfectly valid, or reuse is perfectly valid.
I think that needs to be reported in the record, and this at least followed up.
I didn't know. I mean, I can believe it does happen, but I haven't got
Dumping
any.
of oil into ammonia is part. The other thing is just a comment, the higher DDT values in the river may be related to the fact that that whole railroad watershed was the main banana producing area. They used it for the banana scavenging, which was their main way of controlling banana scavenging.
I think they use some of Lakenna. So it's just downstream from Lakenna that we did our sample.
Any other questions? Thank you once again, John. The next speaker this afternoon is Jens Kruger from Suva, dealing with reclamation and its impacts.
For sure, you know this.
Thanks, Mika. Well, this is a pretty vague topic, but I'm going to concentrate and focus on the possible impact of future reclamation along the Suva foreshore on the hydrodynamics inside the lagoon, which is the water circulation. By way of introduction, I've tried to put together this map here, which shows reclaimed areas on the Suva Peninsula over the last 124 years, and I've just concentrated on the foreshore reclamation, so I haven't really included any backshore or mangrove areas. And on the right-hand side, you can see the 1881 coastline superimposed on a recent satellite image, which shows that Walu Bay and the central business district are actually on reclaimed land. So the city of Suva really relies very heavily on foreshore reclamation for urban expansion. And I want to...
That's the last 124 years.
Yeah.
124 years. Since 1881?
That's an 1881 shoreline.
Oh, okay.
Yeah. And I'm going to show some examples from recent or ongoing reclamation projects down here in the Nasese area, just south of the bowling club, and also near the Watawanga River mouth. So what does this area down here actually look like on the ground? It was reclaimed some 10 years ago, and you can see that it hasn't been protected in any way, so I think the reclamation has probably been eroded by something like 0.5 to 1 meter per year. And in detail, it was actually reclaimed in 2 stages, separated in time, which I've called layer A and layer B here in this image. And it's been reclaimed using Suva Lagoon, and it appears that the very poorly sorted Suva Lagoon, which contains big blocks in layer B, is more vulnerable to erosion by probably wave action than layer A, which is better sorted. And I did survey this area in 1996, and it came into about 2.5 meters above mean sea level. So just keep that number in mind. And moving over to the east side of the peninsula, the Wataranga River mouth, there's two images here. On the left-hand side, an aerial photo from 1967, and on the right-hand side, the same area, 2002 satellite image. And you can see that reclamation is obviously not just contained to reclaiming the foreshore, but also there's heavy reclamation going on here, which Batiri and Brandy have mentioned yesterday as well. And this area is really under heavy development at the moment. So if you actually drive over the bridge here, all these mangroves have now disappeared. And I just want to concentrate on this area here and show you two pictures, first from the north end and then from the south end here. So that's the reclamation. This is the north end, fairly low elevation, and you can see that this is the flotsam from the high water mark. So the water does inundate the reclamation at high tide, and there's couple of kids here collecting firewood. And on the southern end, again, same sort of situation, Suva Lagoon being used as fill material, but also some other stuff here, which included construction waste like car wrecks, plastics, empty containers for paints and oils, insulating foam, etc. And that's why I asked the Captain George from the Ports Authority, I asked him what happens to your sediment that you dredge from Waiwa Bay, which Jim just called a hotspot, and he said it's being dumped outside the reef, which may or may not be a good idea. But the driver actually told me he picks up the stuff from King's Wharf. It's being dredged, the marine sediments are being dredged. Obviously they're contaminated, as Jim has just mentioned. They're being used as fill material here. So just like in Nasese, it's not armored, it's not protected in any way, so during heavy rains the stuff just washes into the mud flats, and wave action also erodes this area. The bigger picture, I did a full coastal zone mapping in 1996, and from Tamavua River to Samambula River, and I've characterized the shoreline and broken it up into components, and you can see that almost virtually no unmodified coastline exists along the 19 kilometers of the Suva Peninsula. Just over 50% is seawall, and then you have revetments, wharf structures, a few beaches, and 22% of unprotected reclamation, which is just over 3 kilometers. And I've told you earlier that the reclamation at the moment is being filled to 2.5 meters above mean sea level. Just to put that into perspective, if you consider storm surge, which is the non-tidal part of the water level, including barometric pressure and wind and waves, and if you have a 50-year return interval storm and you put those storm surge levels on top of your highest astronomical tide, you get in Nasese 2.3 meters, and in Watamanga you get 2.8 meters of storm surge, statistically speaking, every 50 years. So what about the future? Well, reclamation plans have come and gone, and this is the most recent one on the right-hand side that I've come across. This is again the Nasese area. This one here is the pictures I've shown you here, right just across from the President's gate. And the plan is to extend the shoreline, reclaim it by about 300 to 400 meters, and put in things that Suva needs, like commercial offices, shopping mall, high-rise apartment buildings, and residential plots. So I thought, how's this going to, if you do that, how's that going to affect the circulation inside the Suva Lagoon. So I've come up with 3 different scenarios, one being the unchanged coastline, the present state, and then future case A, which I've based on the plans I've just shown you, which is the yellow dashed line. So I've just extended the shoreline by about 300 to 400 meters. And future case B is actually taken from a 1996 proposal where somebody wanted to build an aquarium and theme park on the Nassese area, and I've sort of carried this around to fill in the intertidal areas. And in both cases, I've also included new port facilities. So I've taken these 3 scenarios together with the bathymetry from the last slide, and I've put that into a simple numerical model. By simple, I mean it's not as fancy as Pascal's model, which is 3D and takes into account stratification and river inputs and probably wind and waves. So I've just concentrated on the tide-induced circulation, so the hydrodynamics due to tidal movements. And this is an output from the model using the present coastline. On the left-hand side at peak flood, on the right-hand side at peak ebb. So you can see that the water is rushing into Lauvala Bay and Suva Harbour and carries around here, and same from the other side. So you actually at peak flood you have converging currents shown in this model somewhere around Nassese Point, and the opposite happens at ebb flows where the currents are diverging. So just based on tides alone, it seems to be a very complex pattern of circulation where there's no direct flow between Suva Harbour and Lauvala Bay. And to compare these results from the model, the present, if you can see the white circle here, I've extracted velocities from that point and compared the present velocities to case A and case B. So first looking at case A, we have time on the x-axis. On the y-axis we have meters per second. So this is during a neap tide. So at spring tides, the currents in Nassese Channel seem to go up to 15 to 20 centimeters per second. In this case, it's 7 centimeters per second. So the black line is the present state of water column average velocities, and the orange dashed line is future case A, which is the 350 hectare reclamation. So not very large differences, probably insignificant. It's a very different picture if you look at future case B, which was that hypothetical massive reclamation of the shoreline, and current speeds are reduced by half. So you have large reductions in tidal flow through the Nassese Channel at Suva Point, which obviously has implications where if you look at the current practices where contaminated sediments are dumped onto the foreshore and they're not armored in any way, they're not protected from erosion, you're going to have direct input of contaminants, and they're probably going to collect in the channel because the current speeds are reduced. So again here, the model output at flood flows, the present and future case, doesn't really seem to affect the average current patterns in Lauvala Bay and Suva Harbour, but very significant changes here in Suva Point, which probably controls water movement between the two bays. So obviously it depends on many factors. Obviously location size and the geometry of the reclamation is going to have an impact on the hydrodynamics. I've put in engineering standards, which is the way the reclamation is being done. They're not using any armoring or foundation, and I think Robert mentioned that very quickly you get into Holocene sediments, which are gas charged. So during an earthquake, they might release the gas, and the reclamations can become unstable. So foundation is important. And I've just dealt with the tide-induced currents, but obviously wind is very important. Also waves, long-period swell waves from offshore trends forming over the reef and probably pumping a lot of water into the lagoon is a very significant factor, I assume, and locally generated wind waves. And then you have long-term climatic changes, Southern Oscillation Index is important because the water level in Suva Harbour seems to change quite significantly with the Southern Oscillation Index by up to 20 centimeters. And also global warming and sea level rise could be an issue, especially when you only fill to a height of 2.5 meters. So the impacts are loss of intertidal habitat, and it's very diverse, as we've heard from many speakers, like Gillian. And it's a non-cash food source for many families, for squatter settlement families, and we have, at the moment, minimal effects on the water circulation, but they could be very significant if large-scale reclamation is undertaken. And I've put an increased risk to communities and infrastructure from cyclones and tsunamis, because if you fill your foreshore to 2.5 meters and you put in a seawall, obviously you're going to decrease the effect, the influence of high frequency, low amplitude storms. But these areas will become more vulnerable to the large events like cyclones and tsunamis. And you've put more people and infrastructure into the coastal zone, therefore I've put increased risk. So in conclusion, I should probably mention benefits, because you're adding, Mariah, I think, was from the Suva City Council. She said it's cheaper to reclaim land, which then becomes very valuable, rather than buying property that already exists. So you're creating additional recreational housing in economic areas, so that in future something like that produces revenue. And this is not a picture of the Laumi rubbish dump, but it's from the Watuanga River mouth. Thanks.
Any questions anyone would like to ask? Can I just ask you, it's one of those photos of the proposed reclamation. Was
Yeah.
that Jeff Green's?
I don't know where it came from. Somebody just slipped it to me.
I always have questions. Bill's always ask questions. One thing, in terms of a way of dealing with this, Jen, it would seem to be that, like what has happened down in Rarotonga, is that you could have a system where on the top area, on the reclaimed area, that you could have a plant mangrove associates or coastal trees, and then in front of it, if the environment is suitable, is to plant rise off from some of the outpost zone mangroves, which is what they've done along the new roadway at Rarotonga Village, and it seems to be doing well. The other thing that you didn't mention that may affect the success or failure is the sand supply. In other words, if you're losing all your biogenic sand, you have like 10% beaches. The other thing is we keep building seawalls. Maybe they're less expensive. Malika and I and Ed and just been to Okinawa, and you very rarely see seawalls that fall. You see basically tetrapods, offshore things that absorb the water, and then if they do have a seawall, it's like a step-like thing with holes and absorptive things. Maybe it's beyond our financial needs to do so, but it was just interesting. The Japanese and the Okinawans seem to have developed an art coastal reinforcement. So it's just something to think about.
Yeah, using mangroves, that's a great idea, but I think the dollar value probably speaks louder than mangroves. And then you probably want to maximize your reclamation area, so you're going to fill up to probably a water depth where mangroves can't grow anymore. So yeah, probably you should set back a little bit and let the mangroves do the hard work.
The local water reclamation just goes out on a fairly flat reef slope. They aren't going off into a steep drop off.
Can I just follow up on that? Is there any theoretical limit to the distance you can move offshore with your reclamation?
Well, I think the new port facility is going to be in 30 meters water depth, and then it becomes like an engineering problem where Robert has said, you need to drive piles really deep into the bedrock. So, if you have
There's one line where it brings it to one glass of water through the roof.
yeah.
It's not the territory of water.
Any other questions?
The possible to reclaim some of that, come out, say, a certain distance. Your modeling indicated it would affect the current flow through there, but the next step must be to include those other variables that you mentioned, like the wave action. That's very important, and so is the wind. In which case, then it becomes, at least from an engineering point of view, from the point of view of the hydrodynamics of the two bays, a much more reasonable thing. Do you agree with that?
Yeah, it's it's a great tool, and I've just started working on this, and you can probably use Pascal's model and then put in different scenarios and see. And there's probably going to be a point where the impacts will be significant, and then you just don't go beyond that point, and then you can tell from the model beforehand what you should be doing, what shape, size, and location reclamation should have. Yeah.
Sure.
So forward
shape
thinking.
water, the way you're being influencing that first expansion. If you challenge that initially, if you challenge the text, you have very big influence in the first expansion of particle retention, transport of particle matter. Right. I think it's something that we try to calculate the influence of the change that you can challenge.
Yeah, but he's talking about landfill and intertidal areas, so every tide there's a drawing.
Yeah, but I think you must combine all the influences that are right. And not use only tide or only the wind or only wet. You must combine all. And we are trying that we see that wave and very sure what you are very.
Yeah, in the case B, at high tide, the whole reclamation would actually change the tidal prism by about 1 or 2%, which doesn't sound like much, but obviously locally it's very important. So these things do become very significant.
One wonders how wise it is altogether to keep developing these kind of low-lying, near-coast environments in the view of the potential disaster that could happen to them if there is a tidal wave, like a large one. This whole thing will be destroyed, right?
Yeah.
So why not move further back to Tamahua, or where there is a lot of land, or go into high rises instead of insisting on developing this low-lying land?
Well, it's the problem all over the world. The problem is not like storm waves and cyclones or sea level rise. The problem is people moving into the coastal zone. So that's the problem. So yeah, I agree with you. But I think Suva Peninsula is fairly hard pressed for space.
I also wonder if this stuff isn't particularly well sorted, it's just sediments that have moved out here, how good a foundation this makes for buildings.
Well, that's happened to Wado Bay, and that's built on subsistence, on reclaimed areas and it's subsiding.
Right.
So the tide gauge, which is built on King's Wharf, I think, shows a sea level rise of something like 7 centimeters a year, which obviously isn't sea level rise, but it's the wharf that's subsiding. At the moment, there's a contractor strengthening the whole structure. So in future, yeah, these things sort of settle.
Any other questions again? All right, thank you once again.
Thank you.
Thank you. What I'll try and do at this session is just to give you an overview of the issues related to shipping, the environmental issues, especially in a port like Suva. The four focal areas that I'll touch on are marine spills, ships waste management, port operations, and invasive marine species. Suva is one of the what's considered hub ports in the Pacific, together with Apra and Guam. This slide is taken from work that was done by Ed Anderson and IAS and SOPAC to carry out a marine spill risk assessment. So you can find this is for container vessel traffic. One of the main hubs is Suva here, so you get a lot of the main larger container vessels dropping containers off in Suva, and then gets redistributed around the South Pacific area. And the same thing happens around Apra in Guam. And it's quite similar too with tankers, fuel tankers. So you have a hub around Suva and also in Wunda Point, and the same thing in Apra in Guam. So Suva is not only an important port for Fiji, it's an important port for the whole region. Right? Okay, regulation of shipping. By its very nature, shipping is an international industry. It operates across borders. So the regulation of shipping needs to be done at the international level. The main instrument that provides the framework for that is the law of the sea, and it provides for things like boundaries or jurisdiction. And also there's two sets of powers there that are quite specific to shipping, or the regulation of shipping, and that's flag state control and port state control. If you see vessels, they always have their flag state labeled at the back. So it's the primary powers for the regulation of, to regulate a vessel is with the flag state. And the port state control comes in when a vessel comes into a port to discharge cargo. So there are limitations for a country to actually regulate shipping because of these things. That's why there needs to be a lot of cooperation between countries in order to regulate shipping. And this is all these issues with flags of convenience and all from this flag state control weaknesses. After that, then there are a number of international conventions that are looked after by the International Maritime Organization that cover shipping-related environmental issues. Things like MARPOL, which looks after the environmental discharges from the normal operation of vessels. OPRC covers pollution incidents, oil pollution incidents. The London Convention covers dumping of waste at sea. And then you have some new conventions that came in last year, ballast water, looking at invasive species, and also the issue with TBT, anti-fouling systems. All vessels are painted with anti-fouling paints, basically to make them go faster in the water. But the related problems that John Morrison alluded to has led to the phasing out of those kinds of paints. It's very similar to the ozone, the ODS convention. There's a phase-out period for the phasing out of those paints. There are also a number of regional conventions that mirror the IMO conventions. There are two with SPREP. They're the SPREP Emergencies Protocol and the SPREP Dumping Protocol. And they're the equivalent of the OPRC and the London Convention. There's also quite an important memorandum of understanding between countries in the Pacific Rim called the Tokyo MOU. And it's an instrument that allows countries to collaborate to enforce port state control powers. There was a good example of it last year, where a vessel discharged oil in Melbourne illegally, and it left Melbourne before the Australian authorities could take samples. So they requested Fiji to take the samples here and then send it back to, and they were allowed to actually prosecute in Australia with the Fiji inspectors to provide evidence and actually go there with the samples. So it was quite a useful instrument when you want to enforce a lot of these international conventions. The biggest problem that Pacific countries have is that there's no enabling legislation. Like all conventions, they're worthless in the countries themselves if they don't have enabling legislation. The marine pollution legislation was in the original Sustainable Development Bill, but during the evolution or devolution of the bill itself, that section has fallen out. It's not in that the current form of the Environment Act, and it's something that the Fiji government needs to consider, how you plug those gaps. One of the things too that George Makamba alluded to this morning was the restructure of the maritime sector. We had a situation over the last few years where the Maritime and Ports Authority was both a regulator and also a user of the port. So in some instances you had the Ports Authority regulating themselves. So what's been done now is to move all the regulatory functions to a new agency called the Fiji Islands Maritime Safety Authority, and the Ports Authority becomes a purely commercial port company. And where you had two companies, the Port Terminal Services and the Maritime Ports Authority of Fiji, those have been merged together to become one company providing both services and looking after the infrastructure. One of the other critical areas that I think needs to be considered when they're looking at the restructure of the maritime sector is that the Ports Act had quite a lot of powers also for land-based pollution regulation. And with the move now to have the regulatory powers with the Fiji Islands Maritime Safety Authority, it's a different animal altogether. It's basically a maritime administration. So it doesn't really have any functions for land-based sources of pollution. And those pollution instruments need to be captured by another regulating agency, whether it's the Environment Department or the Suva City Council or somebody like that. Because the form that the Environment Act is at the moment, that's also not covered. To assist countries to put in place the enabling legislation, what we've done with the STC Maritime program is to draft model legislation covering the whole maritime administration area. Three countries have marine pollution acts now: the Tonga, Cook Islands, and Samoa. Fiji was just about to promulgate theirs when the 2002 happened, and since then it's just been sitting there. I guess with the restructure, it's probably a good opportunity to start pursuing that again. And it's good that VT is here because he can push that through the Marine Board. On marine spills, all spill arrangements internationally follow a three-tier approach. Tier 3 is for large spills that are beyond the capability of a single country to respond to. And that's covered through a regional plan that has been approved by all the countries in the region. What it basically does, it splits the Pacific into four, and Australia, New Zealand, France, and the US are responsible for one of the four sectors. The regional plan has been activated 3 times over the last, since 2000. 2 of them were for World War II wrecked spills out in Indonesia. At the national level, you have the national plans. We've done plans for all the countries. Fiji also hasn't reviewed their plan since I think the 1990s. they have this body called the National Oil Pollution Committee that's made up of oil industry, ports, and government. And the main lead agency is the National Fire Authority. What needs to be done is to link that up with the port, because the port has quite a bit of the equipment, like George was saying yesterday. The fire department has the manpower, but it doesn't have any oil spill equipment. One of the other developments that came about with the Port Act was the setting up of an environment levy. I think they make around 100,000 Fiji dollars a year, on the more than that. Okay. So it's a substantial amount of money, and it's basically there for environmental issues related to ports. And it's quite an important thing to have, because when you do have a pollution incident, the last thing you want to be doing is chasing up the finance department to try and requisition money to actually do stuff. So with that levy in place, you actually have the money available to do things straight away. I think one of the interesting discussions that's going on now with the restructure is who gets to hold this money within government. At the tier 1 level, yep. Quite an interesting story too, that with that levy and how it ended up with the Ports Authority, because when we were first negotiating the setting up of the levy, the understanding was that the levy would be with government, with the Marine Department at that time. But somehow I think the Ports Authority saw it as another revenue stream, so they quickly put it to the board, and we ended up with a port-based levy instead of a maritime administration levy.
That's right, because that national committee you're talking about is, I think, a bit defunct. They've, got too many chiefs and no
Yeah, that's a good comment. I think when I was with Shell, I used to get really frustrated with the way that committee was run, because nothing ever happened. It's just going around in circles. With the tier 1 spills, they're the small scale spills that happen as a function of vessels discharging oil or bunkering. And those are looked after by the installations themselves. The oil industry have their own contingency plans. The ports are the ones that are the weak link in that tier 1 level. So what I've been doing over the last 2-3 years is work with the Association of Pacific Ports to put these contingency plans in place, and also with management systems that we'll cover later. One of the other peculiarities too of shipping is the insurance arrangements. Insurance for shipping is not like insurance you get from life insurance or any kind of those kinds of insurance. They're actually self-insured through what's called protection and indemnity clubs. What happens is that groups of ship owners set up a fund where they insure themselves for certain loss of cargo, loss of vessel, spills, and they have what's called classification societies that specialize in doing the surveys in order for a vessel to be registered in the P&I club. The biggest problem for Suva and Fiji, and the Pacific as a whole, is that a lot of the fishing vessels don't have any insurance. They don't have any P&I club cover. Because what happens when a vessel runs aground is that the P&I club covers the cost of any cleanup, and when you don't have that, the situation is what we have around the reef here, where you just have fishing vessels that run aground and are just left to rot. And the only way I think governments can address it is through the licensing of fishing vessels. I think that's the only practical way you really have, because I've tried a few times to actually trace who the owners of some of those fishing vessels are, and they're just impossible. They're just names in Hong Kong or Taiwan or Japan, one room with a fax type setups. This is, so I've just given a couple of shots of a spill in Micronesia, much similar to Suva, where you have a channel coming in. The ship's master decided to take a shortcut, basically hold the hull coming in, and it discharged one of the tanks of heavy fuel oil bunker into the mangroves. So it's something that could easily happen here. It took about 9 months to actually do all the remediation for that very small spill. Ship's waste. There's a requirement for all ports to provide ship's waste reception facilities. What we have in the Pacific is something that's quite unique, where we have regional arrangements to meet national obligations. We're the only region that has this, and basically we had to make our case to the International Maritime Organization. And the thinking behind it is that, especially for small places like Tuvalu, Kiribati, Marshall Islands, they shouldn't be required to cater for international shipping waste. And one of the 6 centers that can receive waste from international shipping is Suva. And the way that waste is looked after is basically by the shipping agents. They work with private companies like Williams & Gosling, Waste Recyclers, Fiji Limited, those kinds of companies, and they take the waste off the vessels. And hopefully they do the right thing and take it to Namboro or the dump in Suva. And vessels are encouraged to discharge waste outside the region. Shipping agents actually try and get the vessels discharged in Brisbane before coming out of Auckland, those kinds of places. Again, fishing vessels are a problem when you look at waste from vessels or ship's waste, because they fall in a category that's called non-convention vessels. They're basically too small to be governed by the international conventions. And the problem too with fishing vessels is that the conventions are meant to look after shipping, commercial shipping. So they're not really meant to look after fishing vessels. So they often fall into a category that's not looked after at all. There's a lot of reliance, like all kinds of other shipping, on flag states to enforce. But when you have distant water fishing fleets operating in the region, we really don't have any interest to enforce. And it's really up to the government themselves when they do the licensing to try and sort that problem out. The thing that George talked about this morning with shore-based toilet facilities, it's okay when the vessel is alongside it, but when they are anchored offshore 60, I don't think the crew will get off, jump along the vessels to get to the port in the middle of the night. So what you end up with is people just going over the side. And if you have 60 or 70 vessels in the harbor, it's quite a substantial amount of fuel that goes in. One of the things...
Are those 959 fishing vessels convention fishing vessels or non-convention fishing vessels?
Some of them, the bigger purse seiners, would fall in the convention. But the longliners, all of them are non-convention vessels. What we've been trying to do too is to lobby the distant water states to try and enforce their flag state powers. In 2 weeks' time, there's a Asia Pacific Heads of Maritime meeting in Korea. And one of the issues that will be discussed is basically the issue of flag state control and getting the distant water nations to actually try and enforce a lot of the MARPOL requirements and FAO guidelines that govern fishing vessels.
Excuse me, sir. No, I think the problem there is most of the things are on for 500 gross ton and over, and most of the fishing vessels are not 500 gross ton. That's why they are exempt from all of these things. So their issues now have to be below 500 gross ton.
But the way around it is there's nothing to stop governments to actually make national legislation to apply to vessels that are lower.
Yes,
That's exactly what Australia and New Zealand does with their legislation. Port operations. We have an environment working group with the Association of Pacific Ports. Last year we adopted an EMS, or Environmental Management System for ports, and it's basically up to the ports to then take it and apply it in their ports. One of the things that we've been trying to do is to help the ports put that in place in their individual ports. It's based on ISO 14000. Okay, invasive species. This is just to show what we mean when we say ballast. It's basically when a vessel comes in and discharges cargo, in order to retain its stability, it takes on water to get it to sit low in the water and be more stable. So that's basically what ballast is. Those are ballast water discharges. And the problem is when the water is taken in, it's not only water that's taken in, it's also the organisms in the water. And the movement of water from one place to the other allows for the introduction of invasive species. And virtually all marine species have a planktonic stage in their life cycle. Basically, anything has the potential to be moved from one place to the other. There was an interesting case in Perth that I saw when we went to one of the shipyards to do a cleaning of, to observe cleaning of one of the sludge tanks. There was a fully grown giant clam in one of those, it actually come in as a plankton, whatever you call them, those, when it was swimming in the water, and just grew inside the tank. And the tank isn't only water, there's also quite a lot of sediment mixed up with it as well. What we're doing to try and address it is to come up with a regional strategy to help countries to address this. The regional strategy is being drafted in a way that the national governments can actually take it and apply it as a national strategy as well. We're also drafting management plans for individual ports and countries. There's a funding strategy with it. And then one of the things too that we've learned with our work with oil spills is that often the technical people understand what they're talking about, but the decision makers aren't aware, or things aren't put in a way that they understand. So one of the things that we're trying to do this time is to do a summary for policymakers, to get the decision makers, or put it in language that decision makers can understand. One of the roles that we hope that USP can play is to carry out port surveys. Cameron Hay, who used to be was quite proficient in doing this. I'm not sure who's replaced him now. I think Ruben was being earmarked for a while to be the successor, but I think he's gone as well. So I'm not sure who here would take that up. The thinking behind it is that we set up the USP and the University of Guam to carry out these surveys, so we don't have to get people in from Australia and New Zealand to come and do that. And it's much cheaper for the ports to pay. Those people. Okay, thank you.
Any questions to Seth?
That was very interesting. On this invasive aspect, I think it's really a quarantine situation, isn't it? The quarantine, Department of Quarantine only deals with basically terrestrial things and some freshwater. Seems so serious potentially, as it has been in some places, that there must be a mechanism for dealing with it at present. Is there?
The way that they deal with ballast water at the moment is they do discharges when they're on voyage. So they do mid-ocean transfers of ballast when they're away from the port. But the problem with that is you have stability problems if there's rough weather. So sometimes they don't discharge offshore because it's just not safe to do it. And the other argument that a lot of people are using is that, let's say a vessel comes from West Coast USA to Suva. Might take them 7 days to come. So they discharge 3.5 days in mid-ocean. By the time the oxygen content in the water has actually gone down, so things probably start dying. So all you're really doing when you discharge and take on water mid-ocean is that you recharge the oxygen in the water. So there's a lot of arguments again, but there's just no other way of dealing with it at the moment.
What about there's no non-residual poisoning or something like that?
People have tried that. They've tried, there's a whole research and development thing, funding that's been provided through the Global Ballast Water Program of IMO. That's been going on for the last 5-10 years. Singapore had a system that they thought worked, but I think that hasn't really taken off yet. I think the only comfort that we can take is that it's a problem for everyone. I was up in North Pacific with the Coast Guard team last month, and we were discussing this over some years, and they said even in the US mainland they have a problem with enforcement with fishing vessels. They're just a very too strong a lobby. They're able to get around this.
Any other questions, sir? Navalik, second. I think we break for afternoon tea and we back at 3:50. 3:20. 3:50 minutes.
Thank you. Good afternoon, ladies and gentlemen. Actually, I'm a part-time student, not a full-time MSc student, and currently I'm teaching next door, Lodala Bay Secondary School. As all of you may have read the topic that I'm supposed to be speaking on, that is ecosystem changes associated with resource depletion or overfishing in the Suva Lagoon. As for this point in time, I'm in no position to confirm such findings since I've just started researching on the topic. That is to say that I'm still on the initial stage. So basically my presentation this afternoon will be on the fishing activities conducted along the Suva foreshore. And that is looking at the fishing effort. And the area of study is from FIT Maritime Complex towards the Veuto foreshores. Fishing effect, this involves three various techniques. As you can see, random record, structured record, and krill survey. For random record, this can be conducted anytime, and the observations such as time, tide, and specific fishing activities, the number of male and female, and the total will be recorded. For the structured survey record, this involves a daily survey for 1 week, and it is recorded 3 times in a day, that is morning, midday, and in the afternoon. For these two, the random record and structured record, I have involved some of my students at school, some of the science students, so especially the students that live within the area, Pony Club area and the maritime settlement behind the complex. So they normally conduct the afternoon survey. The morning survey on my way to work, I normally conduct that survey, plus during my lunch hour, I conduct that survey. So I involve my student in doing these 2 records. During the random record and structured record, these are the following activities that were commonly cited. Gleaning or collection, which most of you must have known that it involves the usage of hands in picking or collecting marine products. And I've noted that Fijian women and young girls, they're mostly involved in this type of activity, especially at low tide or when the tide is just coming in. Fishing nets, we've noted that there are 4 types of nets that are used within the area. The gill net set, that's where the nets are probably left overnight or a few hours in one location and collection is done later. Fijian and Indian men are highly engaged in this type of activity. Gill Net Drive, this is where the nets are left in one position and fish are chased towards it by the fishers. Again, both Fijian and Indian men are involved in this activity. For the cast net, this type occur when net is thrown around a fish or a school of fish, and we normally see fishers on the boat to conduct such activity. probably because fish are highly visible from the boat or from the ponds. For push net, the use of a short piece of net, which is tied at its end to a piece of stick, and it's normally used by females in association with gleaning, especially when entering rocks and crevices or patches of seagrass that are submerged in water. Spearfishing, it's not commonly sighted within the area, but it's associated with gill net, or young boys are engaged in this type of activities. And then we have lantern fishing or Fijian dina. It's the use of source light, example benzene or portable generators. For fishing lines, two types are involved. Hand line, the use of hook and line without any sinker, or a small sinker might be pinched to the line in order to assist the propulsion of the bait away from the fisher, and lines usually thrown from the shore or used in shallow water. And a common sight within the area, you see Fijian women probably conducting waistline fishing. So this is the type of hand line that they normally use. Drop line, the use of hook and line with the addition of a sinker. Again, this is used in deeper water than hand lines. From the random and structured survey, this is the record that is conducted from late November, mid-December, and March. We saw that in gleaning activity, about a total of 567 females, there are 42 males. For fishnet, there are more of males compared to females. Fishing line, almost the same between males and females. That's just a graph, just from the table. To summarize the random and the structured record, found out that the most common activities are gleaning and fish line, and majority of the fishers are Fijian women, followed by Fijian men and Indian men. Fijian women uses push net and a few Gill Net Drive. One of the determinant factor in the type of fishing activity conducted would be the tide. That is, we expect at low tide to sight gleaning, followed by lines and nets, and at high tide, nets or lines and less of gleaning. Other activities we noted include recreation and religious activity. Normally, for religious activity, it's conducted early in the morning. The children's park, a group of Indian men would be usually burn offerings before sprinkling it into the open sea. For krill survey, krill survey is conducted through questionnaires about the fishers' personal and socio-economic backgrounds. It also involves weighing the fisher's catch and also taking photos of the fisher upon their approval. Towards the end of this presentation, then I'll show you some of the fishing activities. The questionnaires are designed to extract information such as preferred fishing grounds, total fish catch, fishing gears, duration of fishing, whether they are full-time or part-time subsistent or artisanal fishermen, and how often do they fish and for what purpose. From November to December and of course March, we managed to interview a total of 116 fishers. Females were the most interviewed fishers, probably because they were able to reach them, especially at low tide, because most of the males were out in the sea conducting the fishing activity. So So that's just showing the number of interviewees from November, December, and March. Again, that's a bar graph showing the difference between males and I think females. I got to put females there. Species we found that caught within the survey for fish, we have Cambatia, or the variegated emperor, Gitawa, the crescent perch, yellowfin surgeon fish, Matu silver body, and Canade. Canade blue-tail mullet, Molisa, and the lowest is Ki Sokisoki, the Vai Nungan Dambea. Those are probably the yellow strip goatfish, porcupine fish, crayfish, and rabbit or spinefoot. Also moray eel. Just to finish off this presentation, these are some of the photos taken. Spearfishing, as I've said, it's not common, but normally it's associated with young boys. We have the Gill Net Drive. You see a group of men involved in Gill Net Drive. And there's this young girl associated with gleaning. You can see there's a catch of a big crab there among the sea grass patch. And she's collecting lumi. Those are some gleaning activities. You can see on the photo that the ladies on the photos, actually they came, they were gleaning on the site, and then this Indian man, he came alone, so he asked for the assistance of these Fijian women to help him with the Gill Net Drive. So you can see on the photo they're probably sharing the fish, dividing the fish among them. Gleaning, Veata is also, as I've said, Veata is a major catch there. And finally, one interesting catch from gleaning, probably, is it look like the Ndambea? Moray eel. Thank you.
Questions, Sarana?
As I've said, I've just started this year, so I haven't really looked. Thank you.
Is there any statistics on the size of the gill nets people use? Are there rules against what size gill net you're allowed to use?
I haven't got any idea about that. Just that I suck at, but it's not, I would have a fair idea about that. frequently fished, but most of the catch is it's just for their consumption. They don't catch much, but the fact that the fishing activities is done.
But I mean, in order to assess overfishing, you'd have to assess the stock that is there or something like that, from my understanding. Because you'd have to quantify how much fish is being taken out, and how much is there for the taking, and then how much of that is sustainable and what is overfishing. So, is that going to be part of your
No,
study?
I'm just looking at the socio-economic importance of fishing.
Oh, okay,
Yeah.
so not overfishing. That is difficult.
Yeah. Certainly it's a topic which is going to become much more important. Overfishing and depletion of coastal resources. Fishing resources. It's something that, of course, is best managed by assessing the resource, knowing the biology of the organisms, and then making management decisions as to, say, with regard to size limits, when you can catch particular fish and this kind of thing. But it seems that something is lacking in the equation, and that is enforcement of these management guidelines. I mean, the fisheries do have quite extensive limitations on what you can take in terms of size. That would be the case, and that it's often listed in the tide tables and things like this. But the one thing that is lacking is enforcement. There is no fishing game officer, no component of the police department. And I wonder how long it'll take before it's considered that it's preferable to have, can we call it, an LTA type situation, where there is a regular inspection of the creels to make sure that there's no duplicate, for instance, because the duplicate is being used,
Yes.
one doesn't know how much it's being used, but it certainly is being used. What are your opinions on that? Do you think that
Yeah,
that's an
it
important
would be good,
component?
but then probably people will be looking at the financing of it, monetary
Well, it's certainly
basis.
going to be very important. I mean, in terms of cost benefits,
Mm.
it would be considered much cheaper to hire somebody to go out and enforce the law than to have the resource completed. And the next question, of course, is the law adequate? That is the management adequate? But that's a whole different situation. If you have management but no compliance, then that seems to be one of the problems that's been persistent for remains to be an issue.
Naka.
Our next speaker is Masarusa from the Mineral Resources Department. And he will speak on natural hazards, basically on earthquakes and tsunamis.
Thank you. We know that tsunamis, whenever they hit our shores, they bring in all kinds of debris from the oceans, derelicts, pieces of coral boulders, as we will see in this presentation. So I begin with by making this statement. Earthquakes and tsunamis are low probability but high consequence disasters. They don't happen every year. I'm talking about major earthquakes and tsunamis. So I will begin by talking about the general tectonics of the Southwest Pacific, and then I'll zone in on the regional tectonics of the Fiji, Vanuatu Islands, and then eventually I'll be talking about earthquakes in Fiji and Suva. Oh, let me go back. Sorry? Microphone? Can't hear me back? Okay. Oh, Can you hear me? Okay. Yes. These are earthquake epicenters. So there's Fiji, and we are situated, we all know that we are situated on the Pacific Rim of Fire, and these orange dots stand for earthquakes that occurring within the Earth's crust. And the red dots are the deep focus earthquakes, mainly from the subducting Tonga slab. And we zoom in on the regional tectonics. The earthquake epicenters seem to align very well with the plate boundaries, Indo-Australian plate, which is trending northeast, and the Pacific plate, which is trending northwest. And Fiji is somewhat situated on a very peculiar plate boundary, mainly made up of fracture zones coming from the terminal end of the Vanuatu Trench and the Tonga Trench. So I'll give you this illustration of what I've just described. There's a northwest trend at 12 centimeters per year in the Tongan Trench, and also northeast trend at 10 centimeters per year. The resultant vector force over the last 43 million years has caused the Fiji microplate to rotate anti-clockwise, somewhat at 0.7 millionth degree per year. These are the cumulative rotation in the last 40 million years. Because of these tectonic settings, we have all these funny things happen in the Fiji microplate, the spreading in the triple junction at the North Fiji Basin, and the spreading Lau Basin, and of course the Hunter fracture zone, which is the major, what we consider the major earthquake source zones that can have an impact on this Suva Lagoon environment. There you go. This is the earthquake epicenter map for the last 120 years, including 20 years of instrumental data gathered by MRD, and the rest are all historical data gathered from various sources. So if you like, it tends to align with the kind of apostrophe shape, indicating the rotation of the Fiji platform in the last 40 million years. And I'll be talking about the assessment for amplification of earthquake shaking by soft soils in Suva, project jointly carried out by MRD, Mineral, SOPAC, and various stakeholders, IGNS from New Zealand. So we'll be talking about the Suva Earthquake Risk Management Pilot Project and the microzonation of Suva using the Nakamura method. So the developments in Suva during the last 50 years has become a major concern in regards to earthquake disaster, and earthquake disaster scenarios were drawn up by the National Disaster Management Office, Mineral Resources Department, SOPAC, in view of a similar reoccurrence of the Suva 1953 earthquake and tsunami. So part of this project was the assessment for amplification of earthquakes shaking by soft soils in the Suva area. We used the Nakamura method. Okay, some instrumentation, just a simple triaxial seismometer and a digital seismic recorder and power supplies, okay, and they came up with results like this. This is the land survey building showing some impression of amplification at this frequency between 1 to 2 hertz. And this is very useful. You all know that this is very useful for engineers, for their designs. When they design buildings, they need information like this. And this is at the Watuanga River. Some impression of amplification between 2 to 3 hertz. And this is the Suva Trapeloid, or the what's now known as the Suva Suva Trapeloids, yeah. And you know, again, a slight amplification. And this shows that there's no amplification at all. Of course, this is the where the Suva Mal outcrops. So they came up with results like this, zonation maps like this. The red areas, if you like, I'll simply state, red areas are areas which will have amplification within the range of 1 to 2 hertz. And these are normally characterized by the reclaimed areas. And yes, SOPAC went a step further and overlay with cadastral maps and property maps to identify the properties that are in the so-called, well, danger zone. And of course, ground acceleration spectra for the seismic zones in Suva, estimated for 10% probability on 50 years with 5% damping. And this is, we're using a period here, not frequency. Okay, on the scenario for the 1953 earthquake, seismic intensity map we came up with was using the modified mechanical scale. This is seismic intensity 10, and in this area in Watuanga, seismic intensity 9, and out on the Suva Mal will be seismic intensity 7. Seismic intensity 10 means that some of the wooden structures were severely damaged, and some of the masonry structures too. Now let's talk about tsunamis. We all know, okay, for the benefit of those who don't know, tsunamis are often caused by earthquakes underneath the ocean. And there's a large earthquake which has a very shallow depth focus. It can cause a fracture or subsidence of the seafloor, causing a movement of the seafloor which triggers tsunami. And now this arrow indicates that why tsunami is very different from the normal surging wave. The entire water column is affected. That means as it travels towards our shore, it can destroy our reefs, you know, and bringing with it whatever is in the harbor. Okay, a tsunami can be triggered by a local earthquake, we call it local tsunami, or by a distant earthquake, which we term the distant tsunami. An example of local tsunami is the Suva 1953 earthquake, and an example of a distant tsunami. Mind you, distant tsunamis too can have an impact on our shores. It's the 1960 Chilean earthquake which killed 436 people along the coasts of Japan and 72 people in Hawaii. Okay, there you go. Also killed 3,000 people along the coast of Chile and Peru, and it was recorded in Sabu Sabu Bay. 2-meter high waves were recorded in Sabu Sabu Bay during low tide, which was rather unusual. A bit on awareness, how you can survive locally generated tsunamis if you happen to be at the waterfront like what we are doing right now. Okay, and during an event of a very strong earthquake, yes, a tsunami may be looming.
Move to high ground or inland for 1 kilometer as fast as you can. Don't wait and watch for the wave. It will travel faster than you can run. And remain inland for some time, because tsunamis are just not just one wave, but a series of waves, as you will see in the simulation model I will show you later. And of course, if you get caught in the danger zone, just climb up a strong tree. Yes. Far below the normal low tide level, you know that the tsunami is looming. Just run. So, in fact, that's the eyewitness accounts of 1953 earthquake. They said that tsunami, the water level in the Suva harbor just receded far below, further than the Suva reef, and then it came back. Okay, tsunami travel time to Suva, if it's coming from, these are tsunamigenic zones. It's recognized internationally. These are all tsunamigenic zones. From Vanuatu, the Hunter Fracture Zone, the Fiji Fracture Zone, right down to the Tonga Trench. It will take about 2 hours. If it's coming from Vanuatu Trench or Tonga Trench, maybe it'll take about 2 hours to reach Suva. If it's within the Fiji waters, EEZ, it'll take about an hour. I reckon we won't have time to issue warnings, especially to the rural communities and the people living in the outer islands. And Suva 1953 earthquake, magnitude 6.7, occurring at a focal depth of 15 kilometers below the surface. Epicenter locations about 25 kilometers southwest of Suva. That's off the Nabua Reef. Yes, it damaged the Suva Wharf. And the map of tsunami, it also triggered a tsunami. We all know that. And the effects of this tsunami recorded about 5 meters, wave height 5 meters in Suva. Number of people killed, only 3. Population of Suva then, 10,000. And in the Kasaleka Bay, because they are in the direct path of the tsunami, Kasaleka and Yale killed about 5 people killed, and population was only about 9,000. Those are the only fatalities recorded. And this tsunami, this is the actual footage of the tsunami, which attacked Suva 8 minutes after the earthquake. Courtesy of National Archives and Fiji Times and Herald, 1953. It damaged the Suva Wharf. This is what the Suva Wharf looked like then. And the Suva Sea Wall, the newly built Suva Sea Wall, was tested by the tsunami. And of course, the Fiji Times photographer managed to take photos of the last series of the tsunami waves.
Was he in the tree?
No, I think he was at a safe height. And notice these boats, they were just piling onto each other. And tsunami waves, when they hit the harbor, they tend to have a seething effect, or if you like, they tend to oscillate in the harbor. Thus the term tsunami, which is a Japanese word, which means harbor waves. And it brought in huge coral boulders like this, examined by our colonial masters at the time. Okay, this illustration, what I suspect why Suva can be prone to tsunami. We are situated on the windward side of the main island, Vitilevu. Of course, we have a lot of rains, and there will be flooding and sedimentation in the harbor, and there'll be build-up of sediments and debris. And if there's a reoccurrence of a 1953 type of earthquake, say magnitude 6 and above, it can trigger submarine landslide and, of course, trigger tsunami. And in actual fact, that was what happened in Suva in 1953. It was a slumping of marine sediments during the 1953 earthquake that triggered the tsunami, which attacked our shores in 1953. Yeah? And that was the suspicion of, they wrote an interesting document, Welland and Skiba and Hoods. They thought that the tsunami was triggered by submarine slumping. And well, their theory has been proven correct by Robert Smith et al., who gave us this data of swath mapping of the super, just outside the super harbor, Robert Smith, from Momi Bay down to where? Nasila, yeah? Yeah. Yeah, and they came up with interesting results like this. You see some very interesting geological features. This is a fault line, this one here, of Neogene age. It's happened some 10,000 years ago. And I suspect, well, I believe it must have triggered a tsunami too then. And these evidence or impressions of submarine landslide. And they located their earthquake epicenter. I mean, when I say they, Welland and Skiba, the epicenter to be somewhere here. And that triggered a submarine landslide and in turn triggered a tsunami. There you go. Triggering this tsunami. Tsunami attack in Suva. Sorry, the animation doesn't work well. Anyway, as a reminder, for locally generated tsunamis, there's no time for warning. So it's very important that we run this awareness program. We visit rural communities along the coastlines to the outer islands, for them to watch out for early warning signs. And some concluding remarks. Suva is now a major political and economic center for Fiji, with an urban population of about 80,000 people, maybe more. So this is 10 times larger than that of Suva 1953, population of Suva 1953. The consequence of an earthquake and tsunami are therefore significantly increased. And Vinakavaleu for your attention. So I will show you some simulation model of the we're using the the Suva 19. Oh, okay. This was put together by PDC of Hawaii. Using the models of the existing buildings and parameters of the Suva 1953 earthquake, triggering a tsunami. The first wave just hit the Walu Bay area. Do I have time? Okay, that's it. I won't show you the rest. Vinaka, time for questions?
Any questions for Asuso?
no.
So what's the recommendation? Is there any concrete recommendation that
Okay.
aside that, the land of cities or coast?
I know, city planners like you guys from city council are wary of us attending meetings. We are not against development. What our recommendations are is that, if you, for example, you're probably referring to the 21-story building, Morris Headstone complex. The sites, the site is a little bit, if I use this term, a little bit suspect, kind of. Lots of thick sediments, some thousands of years ago, the Buccolo stream's been changing courses around that area. So there are lots of thick sediments. What we are saying is that it should be done properly. I mean, the site investigation, and not just a 5-year job, cut costs. And also, sorry I'm using that term. I'm not referring to you, it's the people you buy. Oh, sorry. And, yeah. And, of course, when you come up with the total cross-section, it's got to be engineered properly too. That's our recommendation. We're not against development. Go ahead, it's good for the our economy.
I know you're not against development, but generally, there was some work done by, was it SOPAC or someone, a few years back. Then they came up with some recommendations, I believe, but whether that was passed on our line in terms of implementation, whether that's realistic, whether there's certification, and also there's stakeholders. I don't know how far that is from the Suva was chosen as one of the studies. It's useful, that study. I'm not too sure about the other city and but whether the Microorganisms Department can look at this upon certain standards, some that goes across the board to people that sit in authorities, planners, engineers that are out there working projects. That will be good. There was a recent that research that is on remediation as well. Thinking on these issues and whether they should do it a number of months ahead of autumn plans, because that's when things are ahead in terms of the economy and whatnot, because it doesn't connect them in like to come up with in terms of the factors that consider politically and socially which we're uncomfortable. So that's a suggestion for mineral resources department. Maybe if you have a lot of information, but our stakeholders are not aware of it, that's for that we can come up and share all the information in terms of making it a reality then for that information. That's my concern around it.
For your information, this simulation model, the custodian is SOPAC, not MRD. Yeah.
I thought so.
We'll start with that. And it was put together by a joint project by SOPAC and PDC in East West Center, Hawaii, mainly for our decision makers and developers.
But it really has not been to that the line, perhaps the investigative forum, the organization tomorrow can have to do that. Some of that information is very important. And how it goes on down the line in terms of implementation is possibly.
Am I correct, lad, saying that really, ideally, what we really need is to use that information to help develop the new building code and other such? And I believe through the National Disaster Management Office and others, that's exactly what the money is involved in at the moment. And that basically is the way of translating this sort of information into national building codes, developing a national tsunami response plan, or particularly for Suva, tsunami response plan for Suva. And I believe a couple of years ago, a year ago, we had a scenario or one of those desktop exercises where how any agencies were involved in actually living through
Unaka.
Thank you, Masusa. And our last speaker for the day is Asinava, City Planner, City Council.
Where do I go here? Is it the best you can do it? I hope I can tie up some loose ends at the broad level. When I looked at the program initially, I thought that it was a symposium which was bringing together so many different disciplines, particularly the scientists. And I'm not familiar with work of scientists. From where we sit, it's something that we do not interact with on a daily basis. So it is quite good to be here to be part of this forum. From the opening yesterday, for those of you that were at the opening, I think our minister had already spoken on the role that the Suva city plays in the nation. Suva is the capital of Fiji, as you're all aware, and is the seat of government and the Fiji Civil Services. I think we're also aware of the fact that it also hosts a number of diplomatic missions, a number of regional-based and Pacific-based agencies, and the capital is the main commercial and industrial center of Fiji, and it includes the head office of many Fiji-wide organizations. It is also the center of education. In 1882, it was decided by the powers that be at the time, the colonial powers, that the capital be shifted from Levuka. In 1910, Suva became a municipality. Suva city is located on a peninsula on the southeast coast of Viti Levu, and it's protected by the coral reefs. The peninsula itself projects into the South Pacific Ocean with Laudala Bay to the east and Suva Harbour to the west. Apart from the coastal strip and the peninsula, the terrain of the city is hilly with numerous short streams. The most prominent of these is Nambukalo Creek, which discharges to the harbour in the central city area. I think the majority of the people here would be familiar with the central business district of the city. The major watercourses are the Tamavua River, which sits around about here in the west, which discharges into the Suva Harbour, and the Vatuanga River in the east, which discharges into Laudala Bay. There are a number of major challenges that our city faces, which I'm sure you were able to see yourselves, and I will cover this very shortly. We have a vision for our city as far as our role as a local government is concerned, to make Suva the landmark capital city of the South Pacific with a clean environment. attractive urban spaces, enhanced scenic spots, innovative and diverse economy, and so on and so forth. The city development is, for the most part, supposed to be planned and controlled to promote health and provide better infrastructure, encourage ecologically sustainable economic growth, and with a central human focus of creating opportunities for improving the quality of life and offer sanctuary to all city residents. I think the word ecologically sustainable economic growth, you know, if this forum comes up with the consultation as one of its recommendations, then council at this particular level is already geared up for that kind of consultation, and the vision itself makes it a makes it ready for ecologically sustainable economic growth. But the question is, where to do we go from here, and who do we contact, and what do we do? Our mission is to deliver its vision by allocating the appropriate resources and working in partnership with the local community and international agencies in its project action plans. We have had a few projects that we've worked on with the local community and other agencies, but we have not really advanced to a stage where it is becoming a norm. We are quite new as far as local government is concerned in working with international agencies. I'm not sure whether people are aware of the fact that local governments in Fiji are set up with legislation that are used from the colonial days from Britain. We are also expected to perform the same roles and come up with good outcomes, but the implementation structure, the funding sources are quite different from what the developed nations have. We also have our long-term goal for the vision. I will not bore you with all those things, which you can have a read of, which we can actually produce for you. The second one, the second point, third point, fourth and fifth, you will see are all linked up to having a good platform for getting a better environment. Also, the second last point on good physical planning. This is our legislation framework. We, being local government, that's our very first legislation that we work with, Local Government Act. It tells us what to do, what we're supposed to do in terms of the welfare of the inhabitants of the city. In terms of planning, we use the Town Planning Act. Our health department also uses Public Health Act. Our engineers and planners use the Subdivision of Land Act. We also have other pieces of legislation, including the Rivers and Streams Act, which is probably more applicable or closest at this stage to the topic that we have here today. The number of legislations that we have to go through in order to implement development is quite a lot. I, in my work, use about 13 pieces of legislation to make sure that development projects actually comply with the various legislation and the bylaws that come out of this legislation. Suva has its own town planning scheme. I'm sure the director of town planning at the government level was here this morning, and she may have alluded to this. We work, this is our legal framework, we work with town planning scheme, which consists of the scheme map and which consists of what we call the general provisions. This is just a statement of the policies of development that we have. Also, our city has about 5 different schemes altogether. One covers the whole peninsula, and we have a specific one for the Central Business District. We also have one for the foreshore, a portion of the foreshore. For those of you that are familiar with Suva, it's just touching the land next door to the city hall, the town hall, and moving south towards Nassova Road. That's where the police barracks are, and that's where the GCC complex is going up right now. We also have different schemes for Flagstaff and Nambour. This is just to give you an overview of the legal framework that we work in and the kind of policies that are already available. The very first challenge that we have, which covers everything else, is really the population demand on our boundary. Now we have about 6,466 hectares of land within the city of Suva, whereas before it was just about 200 and something acres when it initially started. The question that we are grappling with is how are we going to accommodate growth, and what does this mean for the environment in general? Whilst the estimated population is 100,000 persons in the evening, which counts for the normal Suva residents, this is expected to rise gradually if the migration patterns continue. The greater Suva region's population, that is between Suva, Lami and Nausori, will rise from one of our estimates from 214,625 persons in 1996 to 338,494 in 2016, out of which we estimate that an additional 50,000 people will be living in the urban Suva alone. It could be more, who knows. On the question of accommodation, we are actually calculating that we will need an additional 10,000 dwellings in Suva, and residential areas will have to be intensified to cater for the population. The other way of accommodating growth is the extension to the boundary. The councillors, who are the politicians elected by the people every 3 years, they are always going on about where is Suva going to move now. Can we cannot go towards Nasinu if you go through the 4-mile bridge. We cannot go through Lami because there's another local government area there. So where do we move? The other option that we are looking at is to extend towards the sea, and to this end we have already earmarked certain areas along the seashore, seafront, foreshore area, perhaps towards that end, where we will be extending the city boundary to. But it is something that we are working on with the Department of Lands, because the Director Lands under the relevant legislation is finally responsible for issuing out these leases or these foreshore leases. Council sees that there's no other way to extend the boundary except towards the sea. For your information, the latest extension approval that we had received was the area in between, along Kiwi Drive, in between the cathedral school and the lighthouse. That is going to go out 30 meters out into the sea with the area earmarked only for recreation. Also for your information, there was a master plan drawn up along the foreshore areas, but the Ministry of Lands at the time had actually earmarked all these areas to be only for recreation purposes. The question that arises is who is going to pay? Because at the end of the day, the economics of the whole reclamation and the cost-benefit exercise will have to balance out. Even the piece of land in front of Government House, we have very strict controls on that piece of land, in the sense that we do not want to see any development. If it was up to me, I really don't want to see development out there. It's just to leave it as an open park because the Government House is right opposite. But then there's always pressure from different angles because there's no more land in Suva to actually develop that area.
Housing demand always exceeds supply in Suva, and there's always an increasing growth of squatters, and these people settle around the mangrove areas or in the swampy land. The latest is just across the road here, and we are taking them through the legal system. Hopefully they will be moved from there in another 12 months after our talks with government on that issue. So that is a big problem that we are facing right now, is people just come in and settle on vacant land, more on land that they know will come to the council or that belongs to the government. For some reason, they have that inside knowledge out there of which land to settle on. So that is another big challenge that we are coming up against. And then we have the people that are the usual ratepayers, the normal ratepayers, that are also harassing us on another end as to why we are allowing them to settle there. So we are into that, we face a difficulty, but more for the lagoon issues, it's more the pollution issues that arises out of it and the quality of life that they live that we are concerned about, apart from trying to make sure that the city is settled in a way which is planned. When reclamation is carried out, we normally request for an EIA. The largest reclamation that has been carried out to date has been the Rokombili port area towards Wallow Bay. They actually submitted an environmental impact assessment on that. Also, there is another one called General Machinery subdivision application, which covered a portion of the Wallow Bay inlet. So maybe with more emphasis on EIA in large projects, there needs to be a coordinated effort with stakeholders, in particular with the Department of Lands, that an EIA is carried out prior to issuing a foreshore lease. We are having it back to front now. The lease is issued first. They pressurize the council to have their reclamation done. And by the time our engineers are assessing the whole work, they're already doing the work. So there's just no point in having an EIA after that. So the pressure is out there politically and also from the business community to get more land going. It's something for this forum to note. Just to conclude, the footprint for development has been set. I don't think we'll ever get away as a city, like any other city, capital city, from the challenges that we have. And I am just thankful, I am very glad that together there's a lot of stakeholders in one forum to try and help us get together all the information to make better decisions, not only for our existence, but the existence of our children and our future generations after that. So thank you very much.
Just something that might be useful to us and others, if you can just outline the development approval process.
Oh, development approval process.
Any new development, just so people are clear.
For engineering works, they're required to submit the engineering plans in terms of the fill material, the slopes they're going to have, so that our engineers can cross-check and make sure that they are complying with all the other relevant requirements that come in. Then after that, they submit the subdivision plans, which allows them to go through the subdivision process, and they are divided then into parcels of land. But what we're facing now is the fact that they are doing that at the same time. They're doing the reclamation and trying to submit all the plans at the same time, and there's just a lot of pressure out there. So I'm not too sure whether maybe it's just because of the lack of education down the line, and also there are people out there that are deliberately doing it. So there's also a deliberate move, and there's always the political pressure as well to get to go for development. It's the thing is, once we are harassed by the top people at the government about how about the reclamation for this and development this, I always turn around and I ask them, okay, but who's going to benefit? Is it really the community at large, or is it really just the developer himself or herself, whoever it is that is going to develop? So that's we're under a lot of pressure to make sure that these things meet. And we also have deadlines to meet in terms of referrals to committees. There's certain things we don't have the powers to make decisions on ourselves. We refer it to the relevant committee. In our case, it's the Town Planning and Subdivision Lands Committee, which consists of politicians. So it can go either way. Yeah, it can go either way. It's a matter of the Western democracy, whoever wins, you know. So at the end of the day, that's what it boils down to. That is the decision-making body. But once it's approved, if there are certain things on zoning that needs to be sorted out, it goes for referral to the Department of Town and Country Planning at the government level. We really don't have the power to make that final decision at our level. Yeah. Our recommendation then will be taken into account at that level.
Those foreshore plans you referred to, are they city council plans, or are they those, there were a number of these different schemes, proposals, developers working? The one you're referring to is
No, it's a city council one. It's a city council one. This particular diagram here, this shows the recreation area is demarcated by Ports Authority. This is the area where the town hall is. Yeah, this is where the town hall is. We also have pressure now. There's a new kind of application coming in now, just for your information. We have some investors coming in, and what they do, because there's no more land, they're opting for to do up some boats or something out there in the sea. And the question that I have is then, okay, what about all the other issues? If you're just going to give it left, right, and center through the Fiji Trade and Investment Board to people that just come in, only because they come in with their stronger dollar, the people are, you know, our people are just giving them the approval certificate from the Investment Trade Board. So it's something, we had to get this drawn up because of the fact that we are getting the pressure to develop along here, or recreation spaces. Even somebody wanted to put up a wide platform along the Bukalo Creek. And already you really just don't need that around there.
Yeah.
Just on the issue of the squatter, I'm interested to know what the council stance on in terms of the squatter settlements and also relating to waste management. Because I know the squatter settlements are not paying the city rates, so the waste cannot be collected. I mean, we're walking in regular squatter settlement and we find that they dump it straight into the creek, and which ends up in the water by it's not far from the coast. So I don't know what the
Well, I was just asking our health department on that particular issue today. And they were saying that they go out and educate people on what they're supposed to do to have something which is much better. People that have links to water supply, they're able to have a good disposal system, whereas the others, I was asking them, what do you do with the others? And they said, you know, if it's something that we are grappling with as well. It's the Ministry of Health also helps out in their own ways to help. You probably know it better than I.
The thing is, with Valia,
Yeah.
they know it's a problem. They don't, it's not right to throw in the creek.
Yeah.
But the problem is they don't have any other option. And we went to the city council and what we were told is because they're not paying the city rates, so we can't do anything about it. So the question is then what do we do? I mean, some of them have been living there for the past 20 years, and it has become their permanent place. They don't have kids there, and I don't know, like, so maybe we can work with you to find out what we can do in that case. But really, the Suva City Council has said we can't do anything because they're not paying the city rates. So where do we go?
Yeah, it's good that you've pointed that out because it's something that we can take up with our health department and see what we can do about it, at least at that level, before they are actually formalized. You know that wireless is part of the squatter upgrading program. It's already earmarked for that, so it's just a matter of making sure that the funds come through. I think it's going to cost around about 5 million or so to get Wailea going. The same applies to the other one across the road, Leindongo. So these are all very expensive stuff, but we have to do it. There's no choice. We acknowledge the fact that we'll have to accommodate them.
We ended up addressing
Yes,
for
yes,
years.
yes.
And then they started throwing it back in the pit because they don't know what to do with it.
Perhaps it's a point that can be recorded in tomorrow's session as well and can be forwarded to us, Milika, that particular point, because then we can pass it on to our health department and see what they can do about it. They're telling me that the Ministry of Health also helps out in terms of giving the advice and all that. So it could be the fact that we just don't have the resources to deal with it. Yeah. So, and we're always looking to government anyway because we see squatters as more a national problem. It's the effect of the macroeconomic policy. Rather than the microeconomic policy, it's really the effect of the macroeconomic policy.
So there was another urban policy plan that was done with funded by, I don't know what the state is.
I think the ministry should be able to tell us that.
It has more to do with the municipal or the urban.
Yeah, I hope that urban policy action plan, which leads to the whole management, better management of urban systems in the country, will come through. I think we're all waiting for it to be referred to cabinet and get the endorsement before the implementation comes through. Yeah.
One last question. What's the latest on the lobby time?
I think our health director can answer that. They're fighting over some ownership or something here between the. I mean, I think the only thing I know is that what was announced on air last week was that it had to go back to tender because the private company that was coming in to share with the other municipal authorities was asking for higher charges, which is just too much on our ratepayers. So all these things have to be taken into account because it affects our environment.
I don't know if you were here for the earlier presentation on land reclamation, but it just when you were showing the impact of the tidal wave, when you were being shown the impact of the tidal wave, it struck me on that map how similar it was to where the land reclamation in Wild Bay was. And it looked like it was very much the same sort of area, reclaimed land seemed to be stuff that was hit most by the tidal wave. And when you're asking for more information on the impacts of the tidal wave, I think it's extremely relevant to this reclamation thing. You're going out and putting out more into the reef area, you're in that high in this area. It's not only sort of a question as a institution really go together.
Yes, yeah. I agree.
The point Softback and also was making was also a soft sediment base in Suva.
Yeah.
That's what we can scale.
And it's not perhaps very small. Yeah, so that's great.
Thank you, Russell.
Okay.
Just before you leave, just one change for tomorrow. We'll start at 9 o'clock, and the first speaker will be Sakyusa Tumuna, not Samsung. So we'll just switch the